Hey guys, this is a clock using an Arduino and an RTC module along with an OLED display. And today, I'm going to show you how to make it. To begin, we'll be using the Arduino Uno R3. You've seen this in a lot of my videos, and it's well used. As you can tell that the sides are rubbing off, but it's okay because we have the pins right here. We'll also be using a 1.3-inch I2C OLED display. The pins are a little bent, but that's okay. And we'll also be using an RTC or real-time clock module. We'll only be using the first 4 pins, so we're not going to worry about the SQW. We'll need a breadboard, and a bunch of cables. We're going to begin by just taking our breadboard and attaching our OLED to it. So I'm going to attach it a little bit down so we can access the pins like that. There we go. That leaves us about a row of pins up here that we can use. And we're going to do the same thing with the RTC. Now I'm going to make the RTC face away from the user just because it's easier to wire, because whenever we're wiring it, we're going to put our wires over here and our, let's see what we can, there we go. Our pin labels are facing us, so that just makes it a little bit easier. Okay, so what the RTC module does is just keeps track of time. So right here is our main chip, and that keeps track of date, time, century, all that jazz. And I believe this is our backup battery. It's a low power battery that keeps the clock running even whenever it's not plugged in. I'm pretty sure that's how that works. I may be wrong, but everything I've read points to yes. So this is our main setup right here. Pretty simple. Okay, we're going to now connect our ground and our power wires. We're going to connect them in the middle. Let's see if we can get that in there. We're going to connect them in the middle. That way this can power onto this side and this can power onto this side without any super duper annoying crossing. Speaking of crossing, let's talk about these two cables. So both of these devices, the OLED and the RTC, they use serial data, or you can think about it as analog data. The thing is, my Arduino has 2 ports that are commonly used for analog, which is A4 and A5. So what we're going to do is we're going to stream analog data from our RTC and our OLED to the Arduino through the same wires. All right, so we'll get that set up here in a bit, but for now, let's go ahead and plug in our power. So let's see, there we go. That's our ground. We're going to hook that up to our negative. And here's our power on the VCC pin. We're going to hook that up to our positive. And then over on the other side, let's go ahead and get these out of the way real quick. On the other side, we're going to do the same thing. We're going to hook ground. Let's see if we can rotate. We're going to hook the ground pin up to the ground, and the power pin up to power. Just like that. So then we should have 4 free cables. Let's see, there's 1, 2, 3, and 4th one's right here. There we go. So these free cables are the ones that will plug into the Arduino. But we're going to see if we can get them out of the way for a bit. Looks like the power one came unplugged over here, so let's go ahead and plug that back in. There we go. All right. So these 2 cables are going to plug into A4 and A5 respectively. This one will take the SDA data from our OLED, and this one will take our SCK data from our OLED. And then we'll do roughly the same thing with our RTC module. It's a little bit hard to see, but we'll plug, let's see if we can get that one in. We'll plug our SDA into the same one and our SCL into the same one as the SCK. So let's go ahead and do that. And that is the board itself wired. Let's go ahead and put this on the Arduino. So first things first, we're going to plug in our ground. Plug that in right there. There we go, a nice ground. We're going to plug our power into the 5-volt. There we go. And now our orange is going to go into A5, or the very last one. And then our blue cable will go into A4. There we go. And now it's all wired up. It's a mess. I should probably look at getting some smaller jumper cables, but I don't know. I kind of like the mess. Alright, so now we're going to code it. So because we're using two things, an OLED and an RTC, we need to be sure that their libraries are installed before we have functions that make it easier to use them. So we're going to go over to this little stack of books where it says, well, it looks like a library. We're going to click on it, and we're going to search for the U8G2 library. LIB. Okay, the one by Oliver, so we want to install that. Just go ahead and click install, and it will give you a little progress thing down here. Cool. You can also click to close the console. Alright, the other one is going to be RTC lib by Adafruit, and let's go ahead and install that as well. Install the dependencies, yes, install those as well. And there we go. Alright, now with that, we are ready to start our code. So the first thing we're going to do is we're going to include those two libraries along with another one. So we're going to say hashtag include. Let's do the u8g2lib.h. And then we're going to include the RTC lib that we just installed. And we're going to include wire.h. Okay. Now we're going to tell the program what kind of RTC board we have. So this one is an RTC DS3231. And we're going to cast that as RTC. And then the fun part with all the with OLEDs using the U8G2 library, you have to write out this long thing. I'm not quite sure what to call it, but it's okay. So it is just, there we go, U8G2 underscore SH1106. That's the model that we have. It's a 128 by 64 size. It has no official name. It's not a name brand. We want full memory access, and its hardware protocol is going to be I2C. All right. Then we're going to do U8G2 again. And then after the U8G2 is going to be U8G2 again, this time in all caps. And we're going to say R0. And then U8X8 underscore pin underscore none. Have I figured out what this all does yet? Absolutely not. Am I going to? Probably not. All right. So now we're in our void setup. And we're going to begin our serial communication at 9600 baud. And we're going to throw in a little alert for us on our serial log just to make sure that the RTC is functioning. So we're going to say if the RTC has not begun, then I just want you to serial print no RTC detected. Then we'll throw in a little while 1. So this next step, there may be a discrepancy between your RTC and the actual date and time it is. So what we're going to do is we're going to use the upload or the compilation date in order to set the date and time for our RTC. So we're just going to say RTC dot adjust. We're going to say date time. And it's going to be date. Whoop. We're going to separate that. Whoop. Separate that with a comma. And do the same thing for time. And it looks like I have an extra parenthesis somewhere, so there we go. Let's just get rid of that. And then in the setup, we're also going to tell our OLED or our U8G2 library to begin communication. All right, that is the whole setup. So let's go ahead and look at line 16 real quick. So in this, we have F, and this is a macro that tells it to store whatever's inside this into the flash memory of our Arduino. And here it's going to store the date, and here it's going to store the time. And I just realized there's a bug with the time. Let's go ahead and there we go. All right. These are also macros, and this one gives you the date, and this one gives you the time. All right, cool. So now let's go ahead and make our loop. Remember, your loop is the main part of the code that will run over and over and over again. So we're going to first set our date time to now. We're going to next say character time buffer. And we're going to give it an array value of 9. And that will be evident on our next line, which is where we're going to use sprintf to call on the time buffer. And we're going to now tell it, hey, how do I want my time buffer or my time displayed and formatted? So we're going to open quotes. Let's click off of that, see if we can. Open some quotes, and we're going to do %02D : Now, the % sign, that's a stand-in. It lets the code know that, hey, this will be an integer, but we're writing it in a string. That's what the %D does. The 02 tells the program that, hey, this number is going to be, 2 digits wide. So commonly we see clocks, like if it's 1 o'clock, it might be 0100. We want it to format like that so it doesn't just give us 0, just give us 1. So we want this instead of this. All right. Now we have 3 spots in time. We have minute, hour, and seconds. So we're going to copy this and paste it, and then get rid of that last colon. And these colons are just literal colons. Like, that's just the separator. So the reason why we set time buffer to 9 is because we have 9 characters here. Let's say we have an hour. Well, let me write this as a string. We have an hour. 1, 2, 3, 4, 5, 6, 7, 8. And then our escape character, I believe it's called, is /0. So all told, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's why our time buffer is 9 characters. Alright, so we've told it what format we want it in. Let's go ahead and tell it what we want it to write. So we're going to say now.hour. This is a method, I believe, from our RTC library. And then we have now.minute. I'm still learning C++, so don't come at me. Now.second. I just want to make cool things and share them with y'all. Alright. So if I say anything wrong, please let me know in the comments. Correct me. Be nice about it. You know, let's all be nice to each other. But as far as I know, I'm telling you what I believe to be right, and if it's wrong, I'll look it up, correct, and blah, blah, blah. All right. So that is pretty much it for getting our time from the RTC. So now what we need to do is just send it to the board. So we're going to copy this guy right here, the U8G2, because that's a pain in the butt to write over and over again. We're going to paste it and do .clear buffer, and then we're going to paste it. So clear buffer, if there's anything in the memory of the OLED, it just gets rid of it. It empties the memory. We're going to set our font. Without this, nothing will display on your board because it needs a font in order to display. We're going to say look in the U8G2 library, find the fonts, and choose this one, NCEN B08 _TR. I use this one a lot. I just like it. It's simple, it's straightforward. All right. Paste that again. And now we're going to draw. Whoop. We're going to draw our string. And we're going to set that at 0, 20. And the first string we're going to draw is just a string that says time, because that's what we're displaying here. And then we're going to draw another string that says 50, 20, and this one we're going to say our time buffer. So that should return to us the hour, the minute, and the second formatted like this. And our time buffer, remember, is 9 characters because of 2, 4, 6, 8. I'm sorry, 2, 3, 5, 6, 8, and then our escape character. All right. And then we're just going to send that buffer, or we're going to send this packet to the memory of our OLED using the send buffer function. And then, because there's a second between seconds, we're going to create a delay of 1,000 milliseconds, which is equal to 1 second. And that should be it. Let's go ahead and put it on the Arduino and see what it looks like. And here it is all wired up. We have our OLED in sync with our RTC, and it's displaying the time. How fun. A nifty little build for a nifty little project. I don't think it has much practicality. I mean, everyone's got a watch, everyone's got a phone, but it's just really neat to do, you know? To make your own thing. Anyway, if you enjoyed this video, don't forget to drop a like, maybe even subscribe, and leave a comment about what I should do next, or what could have been better about this project. Or what you would like to see on this channel. Until then, bye.